sometimes we have what we call multiple reactions. And this happens when you have, let's say, component A plus component B, right? Some reactants. And they are going to be producing component C and component D. But then probably component C is going to be reacting with another component B, and it's going to be producing component E. So these are reactions that occur in series. But we also can say that component A plus component B could yield to C, but they could also yield into another product, which is, I don't know, D, right? So these two are in series, right? But these two are in parallel. So these are multiple reactions that can occur when having certain reactions, and it is important to know how to proceed in order to obtain the balance. For this kind of reactions, we can define the yield as the moles of the desired product that is actually formed, over the moles that would have been formed in the ideal condition. This is when there are no side reaction and the limiting reactant had completely reacted. So this is what we call the yield. And usually the yield is not 1. Usually the yield is less than 1, which means that we're not going to actually obtain what we could have been obtaining if we have this ideal condition, no side reactants, no side reactions, and no limiting reactant. And we can also have the selectivity, which is the moles of the desired product that is formed over the moles of the undesired product that is formed, which you can say that if the selectivity is very, very low, it means that probably you are not getting what you want. But if it is high, it means that you're really getting what you are expecting in this reactor. And in order to analyze these multiple reactions, let's say that we have two reactions where ethylene is going to be oxidized, and then we can either have ethylene oxide, or we can have carbon dioxide and water. And being so, what we are going to state is that the amount of ethylene that we're going to have at the end of this process is going to be equal to the amount of ethylene that we have at the beginning minus, we can say we have 2 times the extent of the reaction of the first reaction minus the extent of the second reaction, because the stoichiometric coefficient here is 1. For the oxygen, the amount of moles of the oxygen that we are going to have at the end is the amount of moles of oxygen that we have at the beginning minus the extent of the reaction 1 minus 3 times the extent of the reaction 2, and so on and so forth. In the rest, which are products, these coefficients are going to be positive. So we can generalize this as the final moles that we're going to have of each component is going to be equal to the final initial moles that we're going to have of each component plus the sum, here we have sum because we have more than one, of each stoichiometric coefficient that happens in each of the reactions. We are going to put here J. So we have, if we have 2, this is 1 and 2, right? Times the advance of the reaction that have in each reaction. So this is how we analyze the multiple reactions in order to have the amount of moles that are going to end up